A classification system is designed and implemented in order to make sense of the chaos. We discussed earlier that the NTSB investigates 1,500 accidents yearly, and that's just in aviation. And the only way to learn from all that data is to be able to make sense of the data. As you think about designing a classification system, any classification system needs to be valid. Valid is suitable for the purpose for which it was designed. There are many types of validity, but for our purposes, as we talk about our classification systems, we will focus on content validity, face validity, and construct validity. Content validity means that the classification framework needs to be all-inclusive. It needs to cover everything. Yet, as it covers everything, it can't duplicate categories. It can't be confusing, can't be cumbersome. Face validity kind of seems superficial, but it is important for acceptance in the industry of your classification system. The classification system you design, it has to look like a reasonable approach that will work reliably in the field. Otherwise, investigators won't use it. Construct validity is necessary to make sure that the classification system captures the true root causes identified during investigation. The system has to capture why, not merely what happened. So those were the three types of validity. Now we're going to get into the 4 factors affecting validity. Don't let that get confusing. The 4 factors affecting a valid classification framework are reliability, comprehensiveness, diagnosticity, and usability. We'll talk about each of those in the next few slides. Reliability refers to the likelihood that independent users will identify similar causal factors and reach the same conclusions during the course of the investigation. In other words, will different people looking at the same data get the same result through your classification system? We enhance the reliability by making the categories simple, with common sense, and by adequately defining them with clear instructions. There are 2 ways of measuring reliability. First, simply calculate the percentage agreement among independent raters. Or you could measure reliability by what Wigman and Chappell in your text call Cohen's kappa. Cohen's kappa is a way to measure the level of agreement among independent analysts that's in excess of that may be obtained by chance. Wigman and Chappell go into more depth into Cohen's kappa. Comprehensiveness refers to the extent by which a framework captures all the key information surrounding an accident. There are several things in opposition to each other here. We want the system to be globally comprehensive. We want it to capture all the information, but we also want it to be detail specific so we can sort the data. So we want it deep so we can sort the data. We also want it wide, globally comprehensive. So we want it deep and wide. However, with depth and breadth together, we risk an overly cumbersome classification system. If it's too complex, it will not be used, and certainly will not be used properly. And comprehensiveness now does not mean that the system has to be large. The system must be comprehensive enough to capture all the requirements, yet simple enough to be useful for meaningful analysis. As you develop categories for the classification system, you're clustering the data. Clustering is really both an art and a science of grouping similar things into one group and grouping different objects into another group. The extent to which the similarity within groups and the difference without yields better, or what we call more distinct clustering. Diagnosticity. That's a weird word. It will draw a red line underneath it when you type it in Microsoft Word. Diagnosticity simply means the ability of the framework to identify areas ripe for intervention. Diagnostics. It is the ability of the classification system to diagnose the problems. That's the root word there. So don't let diagnosticity get you confused. The root word diagnose. How well does the system diagnose the problems? When a classification framework can appropriately diagnose problem areas, mitigation efforts can be laser focused, laser guided to impact those areas, and we don't need to rely on intuition and conjecture, which we're learning is not the best way to initiate risk mitigation efforts. Diagnosticity. Next, usability is the ease and practicality with which the system can be used in real life. This is one of the most important factors because it does not matter how valid everything else is. If the framework is cumbersome, academic, or difficult to use, it will not be accepted in the industry, and if it's not used, no amount of data retrieval is possible. So we look for a classification framework that's easy to use. So we use classification systems to plug data in and get analysis out. We get usable information from a whole lot of data that way. This helps us to be able to diagnose areas needing intervention, allows us to identify trends, and to monitor the effectiveness of mitigation strategies. So now that we have an understanding of what makes a good classification system and why it's important, in 2 more lessons we will research some of the classification systems that are being used in aviation today, both in the industry and in governments. But first, I want to talk a little bit about James Reason's Swiss cheese model of accident causation. That's coming up next.